questions that was requested was 442, which I saw a lot of really good work on, and I'm glad that a few students brought this one up as one to kind of, for me to, supply some kind of like little hint or little just idea to help you move forward if you were kind of stuck on this. So I've set up a nice little pentagon here in GeoGebra, and kind of a big theme for this one was a lot of students were able to prove something about this figure, but their proofs really relied so much on GeoGebra, which is cool. I mean, remember, we don't care about the answer as much as we care about learning and about thinking, right? And about getting the most we can from every problem, not just an answer. So this problem is, can we decide whether or not AHDE is a rhombus and give our reasons? Okay, so that's the question we're trying to answer, but we're trying to explore as much mathematics as we can in pursuit of that answer, and maybe even after the answer. So the first thing to notice is that, clearly we've got a regular pentagon. So we know the interior angles of a regular pentagon. So we know that those interior angles are 108. Good place to start, right? From there, right, we should be kind of using all these strategies that we've learned, right? So maybe I'll label a few more of these. Counterclockwise. So I want you to kind of pause right here, right? So, I guess I may as well just label all these. Oh, there's a quick way to do that. I'm just going to do it by clicking in the polygon, right? Now, we kind of know, right, that the interior angles are 108. So I'm okay with me clicking on this pentagon right here in GeoGebra and saying, okay, all of those are 108, and I know why it's 108, right? It's 5 minus 3 times 180. We've talked a lot about that. Now there's other shapes that are appearing, right? So pause here and see if you can move forward to find some more angle measures. Okay, so you've just paused. Hopefully you're noticing that there is actually an isosceles triangle right here, ABC. So if that's the case, then this angle right here and this angle right here are equal, and are equal to 180 minus 108 divided by 2. So let's calculate that. So that would be 36 over there, and 36 over here. Well, that's helpful because now we know that if this is 108 and this is 36, the whole thing's 108, part of it's 36, then I'm actually going to delete some of these. We know that this must be 72, right? Oops, now I lost that other one. So this must be 72, because 72 plus 36 makes 108. I'm going to get this one back because that's useful. Okay, so we've got 72. So think about how that could be applied to the other triangle up here. So if we go through that same process, right, we look at BCD, we'll get this to be 36 and this will be 72. All right. Oops. And again, I'm using GeoGebra to show it, but I know, and this is the difference, I know where these calculations come from. And so if you ever want to make a video like this and use GeoGebra and explain to me all the ways that you know where these come from, I think that's wonderful, right? And so finally, here's another isosceles triangle. This is kind of cool, BCH, right? So this would be 36 also, which means this is 108, which means this last angle is 108. So at this point, I want you to pause and think about, well, we may not be able to confirm this is a rhombus at this point. We can certainly confirm this is a parallelogram. So pause and give your reasons. How do we know that? Well, a parallelogram has opposite pairs of congruent angles. That's what we have here. So 72, 72, 108, 108. This must be a parallelogram. Okay. So we know this is a parallelogram, right? AE is parallel to HD, ED is parallel to AH. Now the trickier question is this a rhombus? So again, and I saw this in some people's work, they were like, well, this is in GeoGebra, let me measure this, let me measure this, let me measure this. Okay, so it is, and that's what's nice about GeoGebra. It's like, okay, so it is, but what's interesting is how do we know that it is, right? And how can we use some of the geometric truths we've been talking about to confirm that it is in fact a rhombus without having to know any lengths or calculations? I don't know what I'm doing here. Okay, I'm just trying to move this 108 to the side. Okay, well, we have to think about what we know about a rhombus. Well, rhombus is a parallelogram. So we got a parallelogram with 4 congruent sides. Well, we know this side's congruent to this side, and this side's congruent to this side. There are some other properties of a rhombus which we may be able to take advantage of here. So I'm going to go to Math Open Ref, one of my favorite sites, to give you some, maybe give you some ideas to spark your creativity in proving that this is a rhombus. So rhombuses have some properties that maybe we can take advantage of here. Particularly this about its diagonals. It's pretty interesting, right? So each of the 2 diagonals is the perpendicular bisector of the other. So maybe we can try that. I mean, can you prove that these are perpendicular bisectors? Or could you, so maybe pause here. Like, could you maybe draw in the diagonals in? Why don't you try that? Draw the diagonals in. Maybe that'll give you some ideas. Here's a nice idea I saw from a student. What if we looked at isosceles triangle AED and isosceles triangle AHD? Right? What if we looked at those two? Well, they share a common side. We know that they have corresponding congruent angles down here. So there's some interesting things we could maybe do with that one. We could also draw in this diagonal. Maybe we could prove something about how these diagonals intersect. That would help our cause, right? Lots of interesting places you could go from here. So I'll leave that up to you to figure out. Great job.